Motor overload protection requirements are determined by the type of duty the motor performs. The 2020 National Electrical Code, or NEC, clarifies when overload protection is mandatory. Specifically, motor overload protection is not required when a motor is used in intermittent, short-time, or periodic duty applications. However, the code mandates overload protection for motors operating in continuous duty applications. To fully understand this, let's delve into each duty type. Continuous duty refers to a motor operation at a substantially constant load for an indefinitely long time. Examples include motors powering pumps, fans, or conveyors that run continuously during operational hours. Intermittent duty involves a motor operating for alternate intervals of load and no load, load and rest, or load, no load, and rest. Think of motors used in cranes or elevators, where periods of heavy lifting are followed by periods of inactivity. Short-time duty describes a motor operating at a substantially constant load for a short, specified time. A typical example could be a valve actuator motor that opens or closes a valve and then shuts off. Periodic duty involves intermittent operation in which the load conditions are regularly recurrent. This might include motors used in certain types of automated machinery. The rationale behind waiving overload protection for non-continuous duty motors stems from their thermal characteristics. These motors have sufficient time to cool down during their off cycles, preventing excessive heat buildup that could lead to motor failure. In contrast, continuous duty motors run constantly, making them more susceptible to overheating if an overload condition occurs. Overload protection devices, such as thermal overloads or electronic motor protectors, are designed to trip and disconnect the motor from the power source when an overload condition is detected. This prevents the motor from being damaged by excessive current and heat. When selecting overload protection, it is crucial to consider the motor's full load current, service factor, and ambient temperature. The overload protection should be sized to allow the motor to start and run under normal conditions, but also to trip quickly enough to prevent damage during an overload. Article 430 of the NEC provides detailed requirements for motor overload protection, including specific sizing and installation guidelines. It is essential to consult this article to ensure compliance with the code. Firstly, determine the motor's full load current from the motor nameplate. This value is critical for sizing the overload protection. Secondly, consider the motor's service factor. The service factor indicates the motor's ability to handle occasional overloads without being damaged. If a motor has a service factor of 1.15, it can handle a 15% overload for a short period. Thirdly, take into account the ambient temperature where the motor is located. High ambient temperatures can affect the performance of overload protection devices, so adjustments may be necessary. The NEC specifies maximum allowable overload protection settings based on the motor's full load current and service factor. These settings are typically expressed as a percentage of the motor's full load current. For example, the NEC may allow overload protection to be set at 125% of the motor's full load current for motors with a service factor of 1.15 or higher. For motors without a service factor of 1.15 or higher, the NEC may limit the overload protection setting to 115% of the motor's full load current. It is important to note that these are just examples, and the specific requirements may vary depending on the motor's characteristics and the applicable NEC edition. Furthermore, the NEC provides guidelines for selecting the appropriate type of overload protection device. Thermal overload relays are commonly used for smaller motors, while electronic motor protectors are often preferred for larger or more critical applications. Electronic motor protectors offer advanced features such as adjustable trip curves, current monitoring, and fault diagnostics. These features can help to improve motor protection and reduce downtime. When installing overload protection, it is crucial to follow the manufacturer's instructions and the NEC requirements. The overload protection device should be located as close as possible to the motor to provide the best protection. The wiring between the overload protection device and the motor should be sized appropriately to carry the motor's full load current. In addition to overload protection, motors also require short circuit and ground fault protection. Short circuit protection is designed to protect the motor from high current faults caused by short circuits in the motor windings or associated wiring. Ground fault protection is designed to protect personnel from electric shock hazards caused by ground faults. Short circuit and ground fault protection are typically provided by fuses or circuit breakers. The NEC provides specific requirements for sizing and installing these devices. Article 430 covers motor circuit protection, overload protection, and motor control circuits, offering detailed guidelines. It is a crucial reference for anyone working with motors. The location of the overload protection device is also important. NEC Section 430.32 details overload protection requirements and placement for different motor types and horsepower ratings. The code emphasizes the need for overload devices to be responsive to motor current and temperature, ensuring effective protection. In summary, understanding the different types of motor duty and the corresponding overload protection requirements is essential for ensuring motor reliability and safety. By following the NEC guidelines and best practices, you can protect motors from damage due to overloads and prevent costly downtime. This not only extends the lifespan of the motor but also ensures the safety of personnel and equipment. In addition to the NEC, other standards and guidelines may apply to motor overload protection depending on the specific application and location. For example, underwriters' laboratories or all standards may be relevant for certain types of motor protection devices. It is important to consult all applicable standards and guidelines to ensure compliance. Proper motor overload protection is a critical aspect of electrical safety and equipment reliability. By understanding the requirements and best practices, engineers, electricians, and maintenance personnel can ensure that motors are adequately protected from overloads, preventing damage, downtime, and potential safety hazards. Remember to always consult the latest edition of the NEC and other relevant standards for the most up-to-date information and requirements. Furthermore, continuous education and training are essential for staying current with the latest advancements in motor protection technology and best practices. By investing in education and training, you can improve your knowledge and skills and ensure that you are providing the best possible protection for motors. Proper maintenance of motor overload protection devices is also important. Regularly inspect the devices for signs of damage or wear and replace them if necessary. Test the devices periodically to ensure that they are functioning properly. Keep the devices clean and free from dirt and debris. By performing regular maintenance, you can extend the lifespan of the devices and ensure that they are providing reliable protection. When troubleshooting motor overload problems, it is important to follow a systematic approach. Firstly, check the motor's full load current and compare it to the actual current being drawn by the motor. If the motor is drawing more current than its full load current, there may be an overload condition. Secondly, check the motor's operating voltage and frequency. If the voltage or frequency is outside of the motor's rated range, it can cause the motor to overheat and overload. Thirdly, check the motor's load. If the load is too heavy or if there is a mechanical problem with the load, it can cause the motor to overload. Fourthly, check the motor's cooling system. If the motor is not being adequately cooled, it can overheat and overload. Finally, check the overload protection device. If the device is not functioning properly, it may be tripping prematurely or not tripping at all. If you are unable to troubleshoot the problem yourself, it is best to consult with a qualified electrician or motor repair technician. They will have the knowledge and experience to diagnose and repair the problem safely and effectively. In conclusion, motor overload protection is a critical aspect of electrical safety and equipment reliability. By understanding the requirements and best practices, and by following a systematic approach to troubleshooting problems, you can ensure that motors are adequately protected from overloads, preventing damage, downtime, and potential safety hazards. Motor control centers, or MCCs, often house multiple motor starters, each with its own overload protection. Regular inspection and maintenance of MCC are crucial for ensuring reliable motor operation. Proper documentation of motor overload settings and maintenance activities is also essential. This documentation can be helpful for troubleshooting problems and for ensuring compliance with regulatory requirements. Advanced motor protection relays offer sophisticated features such as thermal modeling, voltage and current imbalance protection, and underload protection. These relays can provide enhanced protection and diagnostics compared to traditional overload relays. Power quality issues such as voltage sags and harmonics can also contribute to motor overload problems. Addressing these power quality issues can improve motor performance and reduce the risk of overloads. Energy-efficient motors are designed to operate at lower temperatures, which can reduce the risk of overloads. Consider using energy-efficient motors in new installations or when replacing existing motors. Variable frequency drives, or VFDs, can be used to control motor speed and torque, which can help to reduce the risk of overloads. VFD also offer built-in overload protection features. Remote monitoring of motor overload conditions can provide early warning of potential problems. This allows for proactive maintenance and prevents costly downtime. Surge protection devices can protect motors from voltage surges caused by lightning or other electrical disturbances. These surges can damage motor windings and lead to overloads. Grounding is essential for protecting motors from ground faults. Proper grounding ensures that fault current flows safely to ground, preventing electric shock hazards and equipment damage. Regular training on motor overload protection is essential for electricians, maintenance personnel, and other workers who work with motors. This training should cover the requirements of the NEC, best practices for motor protection, and troubleshooting techniques. By investing in training, you can improve the safety and reliability of your electrical systems. Finally, always remember that safety is paramount when working with electrical equipment. Always energize circuits before working on them, and follow all applicable safety procedures. By taking these precautions, you can protect yourself from electric shock and other hazards. Understanding motor duty cycles, whether continuous, intermittent, short time, or periodic, dictates the necessary protection. Ignoring these distinctions can lead to premature motor failure or unsafe operating conditions. It's not just about protecting the motor, it's about safeguarding the entire system and personnel. The NEC is not merely a set of rules, it's a comprehensive guide to safe and reliable electrical installations. Adhering to its guidelines ensures that motors operate within their design parameters, minimizing the risk of failure and maximizing their lifespan.